Hello student, in this class of rigid payment, we'll be dealing with some basic concepts related to rigid payments which are like as an examination. So first of all, understand what are rigid payments. Rigid payments are those payments which are constructed using cement concrete pavement, cement concrete, or you can say plain cement concrete, reinforced cement concrete, pre-stressed concrete. All these concretes can be used for the construction of the rigid payments. They are designed using elastic analysis. Elastic analysis means when the structure reaches its yield point, you will find that the structure reaches its final strength point. जिस जगह structure yield हो जाता है, that point will become the final strength point for the structure. The rigid payments are designed using the elastic analysis, which is basically the working stress method of design that we'll be dealing in the RCC. When I'll start RCC after this, then we'll be dealing WSM. So this is designed by using WSM. Here in this transportation topic, they're asking question not for the design of the payment, they're asking for the calculation of the stresses. Actually, just understand one something. If this is your rigid payment and you know that below the rigid payment there will be a soil. इसके नीचे होता है soil. This is a soil subgrade which have no limit. Now the point is that let's say this is soil subgrade. This is soil subgrade. And you have this base course. And over that we have a top layer of pavement slab. Let's say this is the pavement slab which we have at the top. This is the cement concrete pavement. Fine. This is the cement concrete pavement. Cement concrete pavement. Now, in this rigid pavement, there is the transfer of load through slab action. Slab action means the load will be transferred like this. It will not be a point-to-point load transfer. It will be a load transfer, the continuous load transfer. The load will be transferred directly from the slab like this. When the load will transfer like this, it will transfer directly from the base course to the subgrade like this only. The load will transfer. This means that this type of load transfer is known as the transfer through slab action. The load transfer through slab action. Because of this only, there are no local failures in rigid pavement. The rigid pavement, if the failure will be there, it will be total failure. That can be the cracking of the slab or anything like that. But it cannot be the local failure. एक जगह गड्ढा हो गया, वो नहीं हो सकता है. It is not possible to have a failure here, but not here. The failure will be there. The failure will be a total failure because this total unit is basically a single unit, and the single unit is a slab. The slab will fail. If the failure will be there, then the total slab will fail. ऐसा नहीं हो सकता थोड़ा slab fail हो गया. It means that the rigid pavement will fail through slab action, but the point is that as the load is transferred directly like this, which is through the slab action, then the soil subgrade, which is rigid, will take some response against that. If you are trying to apply the load of the soil subgrade, which is actually rigid or stiff, the subgrade will offer a resistance. That resistance, which the subgrade offer, is known as the subgrade reaction. The subgrade reaction denoted by K. Subgrade reaction denoted by K is equal to the pressure per unit deflection in kg per centimeter cube. It means it is the pressure which is applied to deflect the subgrade by delta centimeter. So that's why the subgrade will offer a resistance. According to that, when you will apply the pressure, the subgrade will also apply the resistance or the response in accordance to that pressure, and according to that pressure the reflection will be prevented. So this will be the subgrade reaction, and the point is that the subgrade reaction will transfer into the slab and convert that into stresses. It means that the subgrade reaction in the form of stresses will transfer into the slab. Reaction get into the slab in the form of stresses. I told you stresses are basically the response or the behavior. Subgrade is basically the support which is provided to the slab. Just consider like that. If there is a simply supported beam which is having a support at both the ends, Here the support is not at the end, the support is all throughout the slab, along the length of the slab. It means the support will offer the resistance. That resistance is known as the modulus of subgrade reaction, which is the subgrade reaction. Now, that resistance get transferred into the slab in the form of stresses, and those stresses are produced at the interior edge and corner of the slab, which can be the reason for the failure of the slab if not properly prevented. It means that what we have to do in transportation is that we have to calculate the stresses at the interior, at the edge and at the corner because of the reaction which is produced at the soil subgrade. Soil subgrade में reaction क्यों produce होगा? Whenever you do something which is against the nature of the soil subgrade will develop the reaction to support the slab which is present over that. In supporting that slab, the subgrade will offer some reactions. That reaction will be converted into the stresses, which will be distributed all throughout the slab in the form of interior, edge and corner stresses. Fine. This is the subgrade. But here is a point, which is that the slab is stiff in itself. Slab khud bhi stiff hai. The slab is present over the subgrade, and the subgrade is stiff in itself also. It means both of these things are stiff. It means that if you will apply some load over the slab will try to deflect, but due to the stiffness of the subgrade, the slab will not be able to deflect. Also, the slab in itself is stiffer. That's why वो खुद भी deflect नहीं होना चाहता. The slab also not wanted to deflect. But when you are applying load, the slab, if slab try to deflect, then that subgrade stiffness will prevent that. It means that there is a term which is known as relative stiffness. There is a term which is known as relative stiffness, which is defined for the slab with respect to the subgrade. With respect to the subgrade means that there is a term relative stiffness which is defined for the slab with respect to the subgrade, and this relative stiffness is denoted by L. That L is equal to E into H cube divided by 12 into K modulus of subgrade reaction 1 minus mu square. This will be the relative stiffness. This की power 1 by 4. Here E is the modulus of the subgrade, Young's modulus of the subgrade. H is the thickness of the pavement. K, you know, modulus of subgrade reaction, and mu is the Poisson's ratio. When you will just apply all these relations, you will get a relative stiffness term in centimeters, which is the stiffness of the slab with respect to the subgrade, because slab is also stiff, subgrade is also stiff. When slab will try to deflect, the stiffness of the subgrade will try to prevent that particular deflection. That's why the relative stiffness term is defined. Now we know that what we have to do, we have to calculate the value of stresses in this chapter, and the point is that the stresses can develop in the slab in 3 different ways. The stresses can be load stresses. The stresses can be load stresses. The stresses can be temperature stresses, and the stresses can be the friction stresses. These can be the 3 types of stresses which can develop in the slab. Now first start with the load stresses. The load stresses. Now, what are the load stresses? The load stresses are produced in the slab due to the presence of load. Now we know that the slab is basically rigid and it is having joints at its ends. It means if you will consider a slab, let's consider a slab. This is a slab. Now this slab is rigid and it is having joint after each and every end. The joints are present after the completion of the slab. Whenever one slab is completed, there will be the presence of another slab which will have joint between them. Now the point is that because of these joints, the joint will also be here. When the load will try to come over the slab will try to deflect. And when the slab will try to deflect, the slab will try to attain a shape that's something like that. The slab will try to attain a shape which is something like that. Now when the slab will try to attain, this is the nature of the slab, that if your load will be applied over the slab, because of the presence of joint, the slab will be tried to hog. This is known as hogging. You will already completed this topic in the strength of material part, that when you will try to apply the load like this and the support are present at the center, not at the corner, because the corner is open because the joints are present, then the slab will try to hog. And when the slab will try to hog, then there will be the presence of tensile stresses at the top and compressive stresses at the bottom. Just remember the Sohm lecture. Yeah. And when the tensile stresses are present at the top and the compressive at the bottom, then there will be the case where the stresses will be 0, and that particular portion is known as the portion of neutral axis. इसको आपको हमने बहुत conceptually पढ़ा हुआ है, एक एक चीज को फील करके. This is known as the neutral axis. And the point is that this subgrade, this soil, this pavement is not alone. It has subgrade below that. Now, because of the presence of the subgrade, the slab will not be able to hog like this. Why it will not be able to hog like this? Because there is a subgrade. The subgrade is totally rigid. When the subgrade is rigid, it will not deflect. And it will not deflect, rather it will apply some reaction over the slab. Because of these reaction, the slab will get opposite nature stresses. It means that due to subgrade, the region in which the slab wanted the tensile tension will get the compressive region. जहाँ टेंशन चाहता था स्लैब वहाँ compression आएगा, जहाँ compression चाहता था वहाँ पे because of subgrade the stresses will be tensile. It means that as the subgrade offers the opposite types of stresses against the slab, there will be the presence of compressive stresses at the top and bottom will have the tensile stresses. Now we know one thing. We know one thing that in case of concrete, the tension is critical because the brittle material are weak in tension. हमने पढ़ा था. It means that the tensile stresses which are present at the bottom of the slab will be the critical. It means that under when the load stresses will be present, the critical section or the critical portion of the slab will be the bottom portion. Now, you have understood the concept. Now, write the values how to calculate the load stresses. First of all, to calculate the load stresses, you have to calculate the equivalent radius of the resisting section. Equivalent radius of the resisting section. Equivalent radius of the resisting section. Now, what is equivalent radius of the resisting section? This is B centimeter. Equivalent radius of the resisting section means when you are trying to apply the load, there will be a certain area in which the load gets distributed. That area have a radius which is known as the radius of the contact area. Now, the point is that there will be a resisting section on which the reaction will be applied with the subgrade reaction. A certain area on which the subgrade reaction will distribute, that area will have a radius, and that radius is known as the radius of the resisting section. Now, B can be calculated depending upon the value of A. If the value of A is less than 1.724 into H is the thickness of the pavement, then you can say that B is equal to under root of 1.6 A square plus H square minus 0.675 H. This will be the case. B is equal to 1.6 A square plus H square minus 0.675 H. And if A is greater than 1.724 H, then in this case B is equal to A. So you have to check these two cases. First of all, you will check that A is less than or greater than. This H is the height of the pavement or thickness of the pavement. If any of the conditions satisfy, you can just calculate the value of B depending upon that particular relation. Fine. So after calculating the load, this equivalent resisting section, you have to calculate the load stresses. So first of all, the load stresses can be calculated by using the following relation. The stress at the interior, this interior stress will be 0.316 into P upon H square. This is bracket 4 log 10 base 10 hai. This is relative stiffness divided by the resisting section radius plus 1.069. This will be the interior stress. The stress at the edge will be 0.572 P upon H square. You have to remember these formulas. 4 log 10 L upon B plus 0.359. Similarly, the stress at the corner will be, this is this is actually 3 P upon H square. This is 3 P upon H square. This is 1 minus A root 2 upon L to the power 0.6. So these will be the value of the stresses at the interior, at the edge and at the corner. These are the three stresses which you can calculate by using these formulas. Now, actually the point is that these formulas cannot be directly asked in the GATE examination, either in the IAS objective examination, because you cannot calculate these formulas, these relations by using either virtual calculator or apne haath se, you cannot calculate it. You need a scientific calculator to use this relation. That's why these questions cannot be directly asked, but they can ask the questions in comparison. Comparison karke they can ask the question. They will write the equation. They will say that what will be the value of L and something like that. They will not ask directly the numerical question on that, but it's not possible. Fine. This is the load stresses case. Now let's understand the case of temperature stresses. How the temperature stresses are calculated and what are the temperature stresses actually, how the temperature stresses are denoted and something like that. Now next is temperature stresses. Temperature stresses. So first of all, let's understand the nature of the temperature stresses. जैसे आपने अभी पढ़ लिया, load stresses का critical portion क्या होता है? The bottom portion of the slab. Why the bottom portion? The bottom portion is critical because the bottom portion has tensile stresses. That's why the critical portion is bottom portion. Now let's talk about the temperature stresses. The temperature stresses, let's consider a slab here. Let's consider a slab here. Now, for the calculation of temperature stresses, let's first understand how the temperature stresses variation are present and how they occur. First of all, let's consider a slab here. Let's consider a slab. Color change करेंगे इसका. Let's say this is a slab. Now you have to study the temperature variations. To study the temperature variation, you have to first understand how these slab will vary during the day and night. Actually, the temperature stresses are produced due to the variation of temperature in the day and night. For example, let's take the case of day. दिन की बात करते हैं. During the daytime, what actually is present? The top surface is hot and the bottom surface is cool as compared to the top surface. It means there is a temperature difference between these two surfaces. There is a temperature difference which is present. Now, if the temperature differences are present, then due to the portion which is hot, the slab will try to expand, and the portion which is cool, the slab will try to contract. It means the slab will try to create a shape something like that. The slab will try to create a shape something like that, in which the slab will try to contract due to the portion which is cooler, try to expand into the portion which is hotter. It means that in the top region, what slab wanted is that in the topmost region, the slab wanted the tensile stresses. In the bottommost region, the slab wanted the compressive stresses. Whether, as I told you, the slab, which a slab want, which like with what the slab is wanting, which will not be occurring actually because of the presence of subgrade. The subgrade is present at the bottom of the slab. It means the subgrade will work against the nature of the slab. When the slab wants tensile stresses at the top, then the subgrade will offer the compressive stresses at the bottom. As the region where the slab will wanting the compressive stresses slab, the subgrade will offer the tensile stresses. Opposite nature, because the slab is present over the slab and load is getting transferred from the slab to the subgrade. That's why the subgrade will behave in opposite to that of the slab. If the slab wants compressive in a certain region, then the subgrade will offer tensile in that region. It means that now the final stresses which are present during the daytime will be compressive upwards and tensile at the bottom. It means that during the daytime you can say that the bottom portion of the slab is critical, because in the bottom portion there is a presence of tensile stresses. Now let's take the example of during the night time. During the night time, the composed case will be opposite. The slab will try to, like, the top portion will be cool as compared to the bottom portion. The bottom portion will become hot because it will take time to get cooler. It means that now the case is different. The slab will try to have, the slab, or the nature of the slab will have, the slab will try to expand from the bottom. The slab will try to expand from the bottom. That way the slab will be wanting the tensile stresses at the bottom and the compressive stresses at the top. But again, the case will be different because the subgrade will offer the opposite stresses. It means the subgrade will offer the tensile stresses at the top and subgrade will offer the compressive stresses at the bottom. It means that during the night, the top surface will be critical because the top surface will have tensile stresses. Fine. अगर आपने लोड की बात की थी, लोड कहाँ पे critical था? लोड will be critical at the bottom, चाहे day हो चाहे रात हो. But during the day, the stresses, the temperature stresses will be critical at the bottom, and during the night, the temperature stresses will be critical at the top. Now, what will be the value of these temperature stresses? Let's see that. The temperature stresses at the interior edge and corner can be calculated by the relation. The stresses at the interior, this will be E alpha delta T, change in temperature, divided by 2, bracket, Cx plus mu times C suffix y, divided by 1 minus mu square. अभी देखते हैं Cx Cy क्या होता है. S H is equal to, this is E alpha delta T divided by 2 into Cx, or E alpha delta T divided by 2 into Cy, whichever is maximum. जो भी इनमें से ज़्यादा होगा, that will be the answer. Stress at the corner, if you want to calculate the temperature stress at the corner, then this stress will be E alpha delta T upon 3 1 minus mu under root of A by L. A आपको पता है, L आपको पता है, relative stiffness. These are the stresses which are present at the interior edge and corner of the slab. Now, what is Cx and Cy? Cx and Cy are the constants. Cx and Cy are the constants which depends upon the ratios of Lx upon L and Ly upon L, where Lx and Ly are the, Lx is the distance between transverse joint transverse joints, and Ly is the distance between longitudinal joints. Lx and Ly are these cases where Ly are the distance between the longitudinal joints, and Lx is the distance between the transverse joint. Actually, in a slab, there are two types of joints: longitudinal and transverse joint. If you want to see that, then you can see that here. The joints which are present like this, there is a slab as present like this, then the joint can be in two different ways. Now, if you want to just see the joint, then these joints, these are, you can say that the transverse joint. These are transverse joint. If you want to see the joint, these are these joints. These are longitudinal joints. It means that if you want to just calculate the value of Lx and Ly, then these values will be given to you actually. The Lx value will be, which is along x-axis, this is Lx, and this will be Ly. Now, this Ly is the distance between longitudinal, because these are longitudinal joints. Lx is the distance between the transverse joint, because these are transverse joints. Transverse joints are perpendicular joint, like this. Longitudinal joints are like this. These are longitudinal joints. These values will be given to you. Actually, now you have to do what? You have to calculate the relative stiffness. You have to calculate the ratio then, because Lx and Ly will be provided to you. Then after calculating the ratios, you will be provided with the table. That table has, on the left side, the Lx upon L, Ly upon L values. The table will have Lx upon L or Ly upon L values here on the left side, and right side will have Cx or Cy. So what you have to do is that you have to just check whether in what region it is present, then you have to interpolate. Actually, these questions are not asked in the objective examination. They will ask these questions in the conventional examination, that too for engineering services. But it is in the syllabus. That's why I'm just covering this topic for both of the GATE and engineering services. But as I told you that the syllabus of the GATE and engineering services are a little bit different. The approach will be different. So the practice questions that I'll be providing you after the completion of this syllabus will be totally different. The approach will be totally different. The GATE approach will be totally different. The engineering services objective approach will be totally different. I have made the total plan for that. I have made the objective plan for that. And I have made the questions and the approach and the expected question for that. It will be totally different for both of these examinations. But this particular lecture is common for both the examination, because it is a conceptual lecture. You should understand all these things. So that's why I'm just giving you the lecture. This is common for these two examinations. Fine. From here, you can calculate the Cx and Cy values, and after you calculating the value, you can just use these values in the relation which are written above to calculate the value of stresses at the interior edge and corner. Fine. These will be the temperature stresses. The next type of stresses which are present are the frictional stresses. Frictional stresses. Now, what are frictional stresses? Actually, to understand that, the frictional stresses are actually produced due to seasonal variations, not the temperature, due to seasonal variations. Seasonal variations means in summer season, the slab will try to expand. The slab will try to expand. We know that because the temperature of the slab is getting increases. If the slab will try to expand, the slab want tensile stresses to be present. Slab expansion chahiye, tensile stresses will be present, but due to the presence of subgrade, the slab will not get tensile stress. Instead of that, the slab will get compressive stresses. Fine, we know that the opposite nature of the subgrade. Now, in the winter season, the slab will try to contract. Usko kam hona hai. But again the same thing. Due to the contraction, that's what the slab wants. Slab wants compressive stresses. But again the same thing. The slab wants compressive stresses, but it will not be developed there. What will develop? Tensile stresses. Now, if you see these two cases, in summer and in winter, you can see that the winter season, there will be the development of tensile stresses. Summer season, there will be the development of compressive stresses. Now, we know that the tensile stresses are developed in the winter region, and the concrete is critical when the tension is developed, because the concrete is a brittle material. That's why the winter season is critical season. Winter season is the critical season where there can be the failure of the slab. Now, why the failure? How the failure? Because there will be the development of frictional stresses. How the frictional stresses will be developed? Frictional stresses will be developed at the bottom of the slab, when the slab will try to expand or contract. The relation of the frictional stresses will be given at SF is equal to gamma into L into F divided by 2 into 10 to the power 4 kg per centimeter square. These will be the frictional stresses, where gamma is the unit weight in kg per meter cube, L is the length in meters, F, you know, the friction coefficient. You have to use these values in the same unit, and you have to put these values here to get the value of the friction stresses in kg per centimeter square. So now we have at the end three different stresses. We have three different cases of stresses. First was the load stresses. First was the load stress, which was critical at the bottom of the slab. Next was the temperature stresses, which will be depending upon day and night. During day, this was critical around at the bottom of the slab, and during night, this was critical at the top of the slab. Now, the next type of stresses which we have is friction stresses. The friction stresses were critical in the winter. it means that if somebody will ask you, we know that the tensile, अगर total tension develop हो रहा है तो it is critical. Now if somebody will ask you कि what will be the particular critical situation for a particular slab, then you can say that the presence of load stresses during daytime in winter, this will be the critical portion, this will be the critical situation. Why? Presence of load stresses, bottom पे आ गया मानो सिग्मा T, सिग्मा L आ गया लोड का. नाउ डे में फिर से बॉटम, ये आ गया आपका सिग्मा T टेम्परेचर का. अब विंटर के अंदर फिर से सिग्मा W, तीनों टेंसाइल और बॉटम की बात कर रहे हो. यू आर टॉकिंग अबाउट ऑल दिस स्ट्रेसेस यू आर मेजरिंग एट द बॉटम. नाउ बॉटम पे सिर्फ लोड स्ट्रेस डिपेंड करता है और आपका डिपेंड करता है टेम्परेचर स्ट्रेस. विंटर स्ट्रेस वगैरह बॉटम पे डिपेंड नहीं करता, पूरे स्लैब का फ्रिक्शन केस है. इट मींस दैट द क्रिटिकल पोर्शन ऑफ द स्ट्रेस विल बी एट द बॉटम विल बी सिग्मा L plus sigma T plus sigma W. It means that the total stress is tensile stress which is critical. Now here comes another topic which is the objective topic जो इस पे डिपेंड करता है. There is critical combination of stresses. Critical combination of stresses. Number one, during summer season, if somebody will ask you what will be the critical combination of stresses during summer season, देखो summer season में load stresses तो load stresses ही रहते हैं, वो कभी नहीं बदलते, वो वैसे के वैसे ही रहेंगे चाहे summer हो चाहे winter हो. प्लस अगर आप टेम्परेचर स्ट्रेसेस की बात करते हो तो टेम्परेचर स्ट्रेसेस टॉप में आपके क्रिटिकल स्ट्रेस होते हैं, तो यहाँ पे भी आप देख सकते हो कि टेम्परेचर स्ट्रेसेस भी ऐड हो जाएगा. टेम्परेचर स्ट्रेसेस अगर आप बात करते हो फ्रिक्शन स्ट्रेसेस की, फ्रिक्शन स्ट्रेसेस मुझे पता है समर में कैसे होते हैं. कंप्रेशन ऑन लोड टेंसाइल, टेम्परेचर टेंसाइल, तो फ्रिक्शन विल बी negative, तो माइनस का फ्रिक्शन स्ट्रेसेस. इट मीन द क्रिटिकल कॉम्बिनेशन विल बी लोड स्ट्रेस प्लस टेम्परेचर स्ट्रेस माइनस फ्रिक्शन स्ट्रेस. नाउ if somebody will ask you during winter what will be the critical combination, during winter will be load stress plus temperature stress plus friction stress. तीनों चीजें ऐड हो जाएंगी क्योंकि तीनों सेम नेचर के. नाउ if somebody will ask you what will be the critical portion of the stresses at the corner of the slab, now corner of the slab will only have the load stresses plus the temperature stresses because the corner is open and the friction stresses are developed at the base. That's why there will be no development of the friction stresses at the corner. The critical combination will be load stresses plus temperature stresses. These type of questions they can ask. They will give you that the load stress is 100 kg per centimeter square, the temperature stress is 50, the friction stress is 20. Now calculate the critical total stress in winter season. So if you will ask for winter, you will just add them 100 plus 50 plus 20. अगर आपसे पूछते हैं समर में बताओ, just calculate the stresses in summer, this will be 100 plus 50 minus 20. So like this you can calculate. For corner if they will ask, this will be 100 plus 50 at the corner. These type of question they can ask in the examination on the objective case. Now these were the types of stresses that can be developed on the pavement. Now let's go to the another topic for the rigid pavement, that is the joints, which is also an objective topic, joints. As I told you, there are two types of joint which can be provided in the rigid slab. That can be the transverse joint and the longitudinal joints. Transverse joint and the longitudinal joint. The transverse joints are basically for two types, the expansion joints and the contraction joint. The expansion joints and the contraction joints. The longitudinal joints are, these joints are provided by using double bars, and these joints are provided by using tie bars. Now, the expansion joints and the contraction joints are mainly provided to handle the temperature. Also, the dowel bars are used for the load transfer. The dowel bars have two basic functions, if you will understand. The first is to handle the temperature variations. The second is to transfer the load. To handle the temperature variation and to transfer the load. These are the main functions of the dowel bars. But if you'll see the function of the tie bars, the tie bar is the only function to join the slab. No load transfer, nothing. The tie bars is only one function to join the slab. The tie bars are designed for tension. These are designed for tension. They are only one function, that is to join the slab. No other function. They cannot transfer load. They cannot handle temperature variation. They will only design for the joining the slab. The expansion joints has a maximum spacing of 140 meters. The contraction joints has a maximum spacing of 4.5 meter if they are unreinforced, and 14 meters if they are reinforced. अगर reinforced slab है तो contraction joint is the maximum spacing of 14 meter. If unreinforced, then you can say that the spacing is 4.5 meter. Also, the maximum spacing for expansion joint is 140 meters. And in any case, when you are designing the expansion joint, you just have to remember one thing. That thing is that if this is your slab, this draw slab, if these are the slab which we have, now while designing, we have to take into consideration something. That something is that if like these are the slab which we have, now we have to design. Let's say that the initial gap between the slab, there is a gap between the slab. मान लो इतना कोई gap है इसके बीच में. Let's say if the initial gap between the slab is delta. If this gap which is provided is delta between the slab. Now one thing we have to understand that even after the full expansion of the slab, when the temperature increase from T1 to T2, then the expansion will be L alpha T2 minus T1. इतना expansion हो गया, then the expansion will be L alpha T2 minus T1. This expansion should be such that even after the full expansion of the slab, there is a certain gap, a certain space left between the slab, because if the total expansion is allowed, the slab will get joined after the full expansion, which can also be the failure of the slab when the load will be present. That's why we have to take this into consideration, that even after the full expansion of the slab, there should be a certain gap left between the slab, and that gap left will be at least delta by 2. This is clearly specified that even after the full expansion of the slab, the gap which is left between the slab, that should be at least delta by 2. This can only be possible when you will allow the slab to expand here from delta by 4 and also to expand here by delta by 4. Because if delta by 4 expansion will be there, then delta minus delta by 4 plus delta by 4, this will be equal to delta by 2. Then only it is possible to have a delta by 2 gap between the slab. Now, the slab is expanded and we can say that the total expansion will be equal to delta by 2, because delta by 4 here, delta by 4 total delta by 2. It means that the full expansion of the slab that will be allowed is L alpha delta T. This is equal to delta by 2. Or you can say that L alpha T2 minus T1, this is equal to delta by 2, where delta is the initial gap between the slab. Delta is the initial gap between the slab. This is the initial gap between the slab. Fine. Otherwise, इससे ज़्यादा ऊपर allow नहीं कर सकते आप. So you have to just remember that. तो ये हो गया आपका slab की question. This type of question they're generally asking. So this is the completion of the slab. It says Pandit signing of the session. Take care. Bye bye. Have a nice day. Keep on practicing. Keep on rising. Keep on achieving height. That's what I want. Take care. Bye bye.